Okay, so this is going to be part 2 of our coordinate proofs for quadrilaterals. Part 1, we talked about all the characteristics of each quadrilateral and what you needed to show in order to prove that they are the shape that they are. For this one, we're going to do a couple of examples. Before we start, make sure you have a couple of highlighters, a pen, maybe a pencil, do some work. Those are the 4 things that I'm going to use. And there are 4 steps to completing the coordinate proofs for quadrilaterals. The first one is that you need to plot and label the quadrilateral on the coordinate plane. So when it gives you the coordinates, you plot them and label them. Then you determine the slopes of sides, if applicable. Okay? The third thing that we're going to do, we're going to determine the lengths of the sides. If applicable. And again, we're going to write a statement that confirms or refutes the original problem. So let's see what these 4 things mean. And I'm going to refer back to step 1, step 2, step 3, and step 4 in our example. So the first example says, prove a quadrilateral with vertices A, B, C, and D is a parallelogram. So the first thing it says, plot and label the quadrilateral. So -4, -2 is A. Then -3, +1 is B. Then 1, 1 is C, and 0, -2 is D. And I'm going to use my highlighter, green highlighter here. I'm going to connect my dots. So I've just completed part 1. And it looks as though it could be a parallelogram. But we have to make sure. And the way we make sure is step 2, determine the slopes of each line. So for AB, we're going to use a slope formula. Sorry, you can't really see that, so I'm going to do it in pen. I recommend you do it in pencil. And our slope formula is y2 minus y1. So I'm going to go 1 minus a -2 over -3 minus a -4. Rise over run. So my slope for AB is 3 over 1. And the reason why it's 3 over 1 is because, see these 2 negative signs? 2 negatives make a positive. So 1 plus 2. And -3 minus a -4 would be plus. -3 plus 4 would be 1. So AB, my slope is 3 over 1. We're going to look at CD now. And I'm going to do the slope on CD. And that would be, C and D would be 1 minus a -2, and then 1 minus 0. So my slope here, again, 1 minus a -2 plus, so 1 plus 2 would be 3, 1 minus 0 would be 1. So we can tell that these slopes are parallel. And then we're going to look at the slope of BC, and we're going to see that these are both flat lines. We could put it into the slope formula. BC, my slope would be, for B and C, it would be 1 minus 1 over 1 minus a -3. Again, 2 negatives make a positive. 1 minus 1 is 0 over 1 plus 3 is 4. So my BC slope is 0. And then my AD slope would be -2 minus a -2 over 0 minus a -4. -2 minus a -2, we have a lot of double negatives in here. So I'm going to put my plus sign there and there. So we have 0 over 4 again. So my AD for these would be 0 as well. So now we know that they are parallel. And now we're going to figure out what the distance is. And the distance, if you remember, we did Pythagorean theorem. So Pythagorean theorem, you could use your slope triangle. You could also use your slope triangle for your slopes. 3 units up, 1 unit over. So do this, draw a little line down here. Let's slide this up. So for AB, we have 1 squared plus 3 squared equals c squared. That would be 1 plus 9 is equal to c squared. Sorry, I'm running out of space here. It's going to be a little bit messy. That would be c squared is equal to 10. C is equal to the square root of 10. So here is my AB distance would be the square root of 10. Okay, I'll put that on orange highlighter. I'll come over here and I'll notice that CD is going to have the same measurements. 3 units and 1 unit. I'll write it down here. So for CD, since they have the same units, 3 squared plus 1 squared, it's going to get the exact same measurement. So I'm going to go square root of 10. For AD, I'm going to see from AD 1, 2, 3, 4 units across. So 40 units across plus 0 units up is equal to c squared. So 16 is equal to c squared. Square root both sides. You get c is equal to 4. Or you could have just counted those. Okay, that was AD. And BC is the same measurement. Okay, so we have opposite sides parallel, and we have opposite sides congruent. So based on the opposite sides being parallel and the opposite sides congruent, we have proven that quadrilateral ABCD is a parallelogram. Now it says step 4, write a statement that confirms or refutes. So you'd go ABCD is a parallelogram. Excuse me. Because both pairs of opposite sides are parallel and congruent. Period. Okay? What I'd like you to do right now is take a look at that. And again, let's go over it real quick. We determined the slope of AB using the slope formula was 3 over 1. And AB is right here. Then we determined the slope of CD is 3 over 1. It is right there. We determined the slope of BC is 0 over 4. And we determined the slope of AD is 0 over 4, or 0. So we know that opposite sides are parallel. Then we went and we did the distance. And we found the distance of AB by using the slope triangle. You got the square root of 10. And then we did the exact same slope and slope triangle over here, so we have the same values. So CD was also congruent, and I'll put a little AB and CD. And then we had AD over here, and AD was the same as BC because they have the same measurements. Okay? Try this one as another example.